Hello, everyone. Glad to be here back on stage in Milano, especially a special place for me. Thanks for the team for organizing this thing after the period we've been through. So that's great. Congrats. So it was not necessarily easy. So I know that you have a sleepless night. So congratulations. It's a great event, by the way. So the title of the talk today is going to be about data observability. I'm going to talk about it as a best practice, but just out of curiosity, who knows anything I've heard about data observability so far? 1, 2, 3, got a few, like less than 10. Observability in general? Great, that would make my life much easier. Okay, so there will be some example at the end. I'm sorry, it's gonna be 1, 2, a bit of pipe. Sorry, but the microphone has stopped at Python, right? So that tells a lot about the audience. So I'm not like a Python guy, but I have plenty of example in Python. So I will explain what kind of person I am, by the way. So things are cut off, but I should be okay. So I have 20 years of scars in data, not work, but scars, right? Because this is how you learn. I started as a developer in geospatial, great area to work at. Data miner, Java, Python, plenty of things, including Fortran, so plenty of joy with that thing. And also YUI. Who remembers YUI? None. Great. So the pre-ages of JavaScript. Ah, there's one there. Awesome. Yahoo user interface. So they invented whatever we know nowadays. It was awesome and awful at the same time to use. So the 5 years after, actually, when I was actually, struggling with on-premises and a closed source application to do manipulation of data, I was using terabytes of data in the early 2000s, and they were mainly pictures. Satellite images with 13 bands and stuff like that. And I was a little bit sad using only closed source stuff, so I looked at what existed back then out there, and Spark, was really appealing back then. So I guess that you know about Spark though, right? Spark, anyone? Spark, Apache Spark, of course. Not the Spark machines, for the late 90s. So Spark, and then, so I decided to work more with Scala and this kind of distributed technologies. Before I have started as a consultant in Silicon Valley, it was interesting. I was giving training in Silicon Valley about the technology that was created in the Silicon Valley. And I'm from Belgium, by the way. So, and there, actually, because I was doing data science work from the console, I started to be a little bit pissed not being able to versionize my code or to deploy my code or whatsoever from the console. So I worked on a tool that was called the Spark Notebook. I don't know if anyone remembers that thing. It was pre-Jupyter. It was at the era of IPython. I don't know if IPython rings bells for you guys. And these were very great years where I discovered that we're going to hit a wall with data at some point in time. Why? Because I remember back then we were saying that data scientists or data people are cowboys. They're outlaws. They do whatever they want and they go to production without any rigorous process or whatsoever. And it was true, and somehow it's still kind of true. Of course, MLOps, DataOps has evolved since then, but I discovered that when working with huge companies that they had really quickly no idea about what they were doing with the data. Literally, they had thousands of data sets and they have a lot of pipelines, but after a few months, they had no idea which data was connected to what database in order to support which business case whatsoever. It was like a mess, right? And eventually, when people were pissed off because data was not matching some expectations, of course, they were running all over the places like chickens without heads, right, to try to find out where the data was wrong in the first place and try to debug RDD codes, if you remember. So I decided to create a company in order to solve things like that. Besides that, I'm an author, so currently I'm authoring this book, The Rally, which is the fundamentals of data observability. There is a QR code which allows you to download the first 2 chapters for free. Why the first two chapters? Because I'm writing the third one and the fourth one. So, so other chapters will come along as I publish and deliver them. And I'm late, of course. So the agenda for today. So you know who I am, what I've been through, so what I've discovered. So why am I here talking about data observability? I'm going to talk about observability and data. You see that I flipped the word on purpose. And I will discuss about something that you should be actually pretty, is going to be pretty, how to say, trivial for you guys, but in data word actually is pretty, let's say, non-natural, the way I will explain how data observability can be applied into pipelines. And I'm going to use some Python code. I promise I can also explain this in other languages. And in order to collect some questions and debates and remarks or whatsoever, I propose you guys actually to connect to the Slack channel that we have with the live show, and I will try to go to the Slack channel afterwards in order to answer any questions now after the talk, right? Or of course after the talk is gone, and then we can keep the discussion going, because I can tell that data observability is a great topic and everybody is trying to define it, right? And this is why writing this bloody book is taking me so long. Observability and data. So, observability, a lot of people have asked me, okay, how do you define data observability? And generally, I am answering that I cannot really define data observability without taking a little bit of height. So in order to define data observability, I'm talking really about observability first, that everybody knows here about, right? So you know that observability is an ability of your system to express what's going on internally, right? So the system knows how to propagate information about how it behaves. Why? To allow an observer outside of the system to understand what the heck is going on when there is a problem, essentially. Not only when there is a problem, but generally we use it for that purpose, right? So it's an ability, it's something that we have added in the system to allow this. And it's not about someone who is SSHing in a server trying to fetch some logs or look at the top or whatever. This is not observability, this is checking, right? Monitoring whatsoever. So this is something different. Observability is an ability that we have anticipated in the system. So, and there are, in my opinion, at least 6 areas, right? So I created a cluster. Of course, they will be pretty rough, right? I'm open to any discussions, of course, but I try to create clusters of observability. First, there is infrastructure that everybody knows, right? Collect information about network, CPU, whatever. So this is observing how the infrastructure is behaving, right? This information are propagated in order to use it afterwards. And then there is application, software, right? So how many threads are used by an application, the system, the application logs and stuff like that. These are all in order to understand how the application are working. Security information also, observability, how security is being applied, and what are the impacts of using security strategies versus other and stuff like that. So how security is behaving. User and purpose. So this is the one that maybe sometimes is questionable, I would say, is how user, right, the system of user, right, are actually behaving with the whole system that you have been putting in place. Analytics is another one, how this system is used to perform analytics, right? So machine learning, transformation, whatever. So these are the analytics, so how the analytics are behaving, right? And finally, data, right? I put data at the end, actually, in order to make it more clear, I should have put data before, because you cannot run analytics without data. But data observability is just one of the area of observability, okay? But you see that the different areas are all intersecting, right? So there is no like, okay, we are going to have different observability that are totally distinct. This has no sense, right? These all areas are just describing one system, right? So these are somehow features. So in the machine learning terms, there's a feature. These are columns that you can use in order to understand how your system is behaving, right? So they are intersecting because the way infrastructure will depend on how the application are actually behaving. The application will depend on the behavioral application will depend on how the data is behaving. The amount of data that is coming in the platform, the type of the data, etc., etc. And of course, the whole system will change depending on what kind of analytics is currently performed, right? And how many machines are available and stuff like that. So everything is entangled somehow, right? So doing infrastructure application or whatever independently from the other is just, looking at the system with limited view, let's say. So this is observability in my opinion, and this is what offers a visibility into your system. So the thing is that most of you, of course, knows about observability, but maybe little about data observability. However, it's still a part of it. So what do we have in observability for different areas nowadays that we can use easily? We have syslogs, we have top information that are provided in the logs, we have root information in order to understand how different machines may be connected through networks and stuff like that. So this information that we collect for ages now. The new ones, open telemetry, open tracing, and obviously our favorite Log4j, which had a great reputation recently, are producing a lot of information in order to understand how applications are behaving. Securities, we have security logs, we have traces, how a security is applied. We have also, for the users, we have git blame, right? So we can use git blame in order to understand how the user has interacted with the application, but of course, audit logs are information that is providing information, some meta information then, right, about how the users are interacting with the system. And finally, data and analytics, and combining both areas at the same time for now. So what are the type of information that we would be interested in order to observe data? So I'm going to pause on that, right? We cannot observe something that doesn't move, right? It's kind of hard, right? So, but data doesn't move per se. So I like to say that generally data can be printed on paper, right? So it has a state, and then you can print it, and then you can use it still, right? But therefore, a sheet of paper cannot actually tell you anything. It's dead, right? So what kind of information can we collect about the data and analytics in order to make them observable? So in order to answer these questions, I'm starting from the use cases instead, right? Otherwise, we don't see the benefits. We don't see why it actually is interesting to think about introducing data observability in your system. So the question that we are asking ourselves during an analysis, I'm talking about a problem that is happening with data. So by the way, has anyone encountered any problem with data in his life or life? Yes, cannot stop laughing. So, well, basically, what kind of problem do we have? Completeness, the data is skinny nowadays, I don't know why. A lot of null values. The data is super old, not fresh, right? We have variation in the data like crazy for, I don't know, events like COVID, right? So the variation of the data is insane, and we don't understand why. We never understand why. We have not been notified. The only person who notifies us, right, that something is going fishy in the data is actually the stakeholders. The business is running some BI, whatever, machine learning, don't know what, right? Who is taking decisions upon the data, at some point knock at the door and say, okay, the data is crappy, please fix. So, so during this please fix phase, right, so we're going to ask ourselves a lot of questions. But how do you use the data, right? So the person is going, okay, so it's crappy, but what do you mean by that? How do you use the data, right? So what we want to understand in order to fix the problem with the data, might it be because the data is missing, is what kind of analytics is performed, what kind of application is running on top of this data, or what are the different goals, right? In order to infer what should be done. And to do that, right, to have this kind of information, we can use two types of channels to propagate this information. Something called lineage. Are you familiar with the term lineage? Right, a few, right? So lineage is dependencies, in a way, right? Propagation, so provenance. So the data comes from this data, that comes from this data, that comes from this data, right? In a service mesh, is like, the distributed transactions, and you know which service is called during the processing, right? It's lineage is the same thing, but for data, right? So you can use this information to understand, oh, okay, the data is created from this data, then this data is created from these sources in SAP, whatever, right? And then you understand how the usage so what will be the usage? And of course, log, right? So you basically log what you've done. Another question that takes a lot of time actually to understand and to have the answer for is, okay, it's crappy, but can you define what crappy means for you, right? Generally, you have little information, little interesting questions. First, because the person is pissed, right? Data is not good, so they cannot work. And also, there is no real expectations generally from people. So they don't know why and how the data should look like. They just see the data is wrong at some point in time, but they never thought about what kind of expectation they had on the data. And this is something in the observability that we can fix with rules, like in Kibana, right? So these kind of thresholds or whatsoever, these are expectations, something that you expect to be true, right? And this is in production, of course. Where is the data? It's crappy, but where it is, right? So where's the table? Where are the files? I have no idea where they are, right? So by the way, I didn't even write the data myself with the application. So I just landed here, and because I'm the new guy in the block, right on the block, I have to fix your problem. I have no idea what the data is. So this kind of information is easy. Is logging in information about what are the tables used in the application that this person is actually expecting to use. What does the data represent? So what kind of information do you use generally? Name, first name, address, whatever. This is information that you have to ask if you don't know the data yourself, because you need this information to understand what is null, what was null in the past also. So you need to understand the structure in order to anticipate maybe that the data was there before and it's not there anymore today. Also, what the data look like. So that's the hardest part. So nowadays, we have to, know, let's say, that we generally don't know what's going on with the data. I used to say that the data is a silent killer. Because you know when you develop with your data, let's say your table, you're working on some SQL or some whatever, ORM mapping, and then you extract the data and then you transform it, etc. But you build a lot of assumptions about the data. The data you consume have the structure. The column is over there. You have so many rows in there, etc., etc. You build a lot of assumptions, right? But when you run your application in production, everything can change, right? For whatever reasons. Right? It means that when the application is running in production and getting data from everywhere, you have no idea what this data looks like. Right? So what you want to know is not only metadata about the structure, what kind of field do I have, the types and everything, but you want to have also metadata about the content. How many null values I have in general? How many rows do I have? What is the distribution, the minimum, the maximum, the average, standard deviation, whatever. So you have to understand this in order to understand the behavior of the data. This is where we're getting close to the data itself. And has anything changed in the past, right? So if I had a minimum value for an edge column that was 35, at some point, if it's 12, right, I want to be aware of that, right? And I have to understand that, right? Because I will not have this information coming from anyone else if I don't see it. Sorry, and this is the kind of metrics that you can get from data. And finally, I'm closing this with a lineage. Because I've been there, I can give some examples, right? So where the data come from? Because the problems in data are not appearing by magic, right? The problem in data are always a cascade. So there is a great paper from Google, which is data cascades in high-stake AI programs. So basically, an error happens somewhere in the data, and then this problem propagates everywhere. These are cascades, right? Also known as garbage in, garbage out, right? So garbage in, garbage out, garbage in, garbage out, etc., right? So in order to understand when the first garbage in was encountered in your platform, you have to understand where the data was coming from. And this is what the data lineage provides you. A way to browse back to the data, which was initially wrong, but the lineage per se will not tell you which data is wrong. In order to understand which problem happens where, you need to mix two information, lineage plus the metrics I was talking about. And finally, how the data is created by the applications. Again, the data are always created by an application, right? We don't go in tables and write data by hand. Right. So there is always an application that reads data, transform the data, and write the data. Right. So which application are part of the system? Because at the end, if we have to fix the data because it was null, right, we have to change an application, right? Or the data was wrong, provided by the third party. So we have to come back to the third party and let them know that, hey guys, the data is crappy, please fix. Now, what is data observability then, right? Data observability is just a component of observability. You know about observability, it's about logs, it's about metrics, it's about traces, right? In data observability, which is a component of observability, it's an ability of your system to provide information about how the data behaves in your system and can impact it, right? So you have the same type of logs, metrics, and traces. Traces are generally implemented as lineage. That's all, right? An example of how data can influence your system. You start using, so there was a great talk about Pulsar, right? So you have a system that is reading a lot of data constantly, right? And you have an application that consumes this, right? But it's, let's say, local, right? Because you know that you're consuming a topic which is relatively small, so you have different topics. This one is kind of okay, so you don't have to deploy a big application. But at some point, you have a big peak, so everything is growing in this topic for whatever reason. Maybe people are publishing into this topic by mistake, or there is a event in the world that is generating more information for the specific topic, and the application blows, right? So you will have an exception that will tell you something like OOM. Why now? Why do I have an OOM now, right? So of course, the heap has blown, right? So you want to be able to correlate this with the amount of data that just has been created. So that's the only thing that we can do in order to first initiate the process of discovery. Now, that we understand, okay, so now we want to have information about the data within the context of your application, which I call data observability at the source, right? We will see how we can do this, right? So what can be done in order to fetch this information, because this is where the data world is struggling the most. There are multiple ways to do this. And the way I'm going to talk about is going to use heavily the power that have engineers, you, right? Instead of relying on some AI that are scanning the data, right, regularly in order to tell us that, oh, apparently the data is wrong, right? We're going to do something different. We're going to embrace, right, some responsibility of figure out how the data is behaving, right? Why? Because we want to understand, what is the quality of our work. We generate data with our application, so we want to make sure that when we deploy an application in production, the data that is generated is matching some expectations, some rules of quality, etc. And this is something that is quite new in the era of data of nowadays. For those that are not data engineer or data scientists, etc., it's interesting to understand that generally when we write a data pipeline, right, we don't even check nulls. It's like you receive an HTTP request, and we proceed with the JSON that is in the payload, like without testing anything. We just throw it into the business logic, and then whatever happens, gonna happen, right? So this is how data works nowadays. So we just take the data as it is, and we put it into the engine. So no preconditions, no post-conditions, nothing. So basically, we hope that everything is gonna remain the way it was before. Which seems odd when we are an engineer, right? But the thing is that the people are not doing this on purpose, of course. It's just that they don't have the tools in order to help them introducing checks and control. Also, there is something that I'm trying to change also with the book, is that there are two behaviors that are conflictuous in the world. Is the data engineers are creating a machine that generates data. So it's like the engineers are creating a bread machine, right? So they create the bread machines that makes bread, right? They don't feel responsible of the quality of the bread, right? So we expect the cook, whatever, is to be responsible for that, right? But on the other hand, the data users who are not creating the application that generates the data don't feel any responsibility with the application, right? But expect to have the greatest data of all time. So basically what they expect is to have the data of quality 100% all the time. This is what they expect. 100% all the time. For engineers, it's like having SLA 100% all the time, right? And you know what? They don't even know what 100% would be, and of course all the time is okay, but what 100% would be is not even clear for them. That means that the threshold, the quality is always changing in their mind, but the engineers are not even aware of that. So this is why engineers are not creating precondition or postconditions, because they have no idea and they don't feel responsible for it either, because they don't feel the support of the people that are requesting the data. And this is something that has to change. It's not gonna be a technology, it's gonna be people behavior. Now we need to have support from technology. And what we're going to do now is to introduce a data observability in the application like we do with any observability. Like Prometheus, we have the agents in the applications, in the machines which are producing information. We're just going to do exactly the same thing, but with the data applications. So in order to, what do we have to do in order to make an application observable, a pipeline observable? We're going to extend it. We're going to create the ability in the applications. So here we have a pipeline that consumes some CSV files, right? Because CSVs is still the most used data set in the world, right? So let's be honest with that. So we have these CSV files and they are used in two different pipelines, right? So on one side, we just have the classical data warehouse flow here that is creating some intermediate data set, let's say in the data warehouse, and then we have the data mart that is created with using dbt. You know dbt? Who knows dbt? A few, right? dbt is like GSP, in my opinion. So it's like you have GSP page, right? So, or PHP, right? So you can write SQL with some extra code in order to check it or whatever. So, but it's mainly for SQL. For whoever remembers a GSP. dbt will take the data and create what they call data model, right? In this case, it's gonna be in Postgres. And then you have another dbt that will create some view that is used by the marketing team, for instance, which is a view on the contacts. And then, of course, we want to leverage more analytics. So we have another one, which is consuming the same kind of data, the CSV files, right away, because, man, the data scientists won't use the data warehouse. Are you kidding me? The data is crappy over there. So I want to use the CSV directly from the lake. So they use the data science, the original files, right, with a training Python program, and then they have the prediction. So this is the pipeline. This is the first anti-pattern that I see in data observability most of the time, what I call the Kraken anti-pattern. The Kraken anti-pattern is, okay, you know what? We know we want to be aware of the data quality or whatsoever. What we're going to do is to add another piece of architecture in another piece of software in architecture that is going to check everything, right? It's like having a small robot into your service mesh or whatever that is scanning all the bloody machines to see if they're okay, right? So, but the thing is, so this kind of data quality checker, analyzer, scanner, whatever you call it, right? For me, as a originally hacker, right, it's the best, it's the best place ever. You know why? Because this computer in the bottom here has all the keys to access all the data in my environment. So if I have to find a door in my system, I know exactly what I'm going to tap first. Moreover, because this thing is consuming all the data in your infrastructure, right? You need to have a dedicated resource, a cluster whatsoever, in order to, of course, read the data and fetch it and compute this information, metrics, lineage, whatsoever. So it's expensive. There is a lot of maintenance. All the rules are there. And guess what, right? Because data quality is generally thought as a business problem, right? The rules will be written by business people because, well, they can write rules, right? And therefore, when someone comes to you and say, look, the data is crappy, see, my rules is failing, the next thing you have to do is understand what the heck is this rule is, right? Okay, but what did you mean with this rule, et cetera, et cetera? Why didn't you tell me before that I had to check these things instead of writing rules after the fact that I'm not aware of? Now the data is crappy for 2 weeks and no one is aware, and you're of course pissed at me, but we could have done something better. So this is what I call the Kraken anti-pattern, and there is one that I prefer way more, but that's probably my engineering background, is what I call data observability at the source, right? That means that instead of checking the data, we're going to flip the problem. So we're going to extend our applications, all the applications, to produce information about the data. The data that goes in, the data that goes out, and how the data is being processed, right? Why we want to do this is first because we have distributed the computation at first, right? So that means that the data is, the information is computed and aggregated and extracted directly from the applications. Moreover, we can leverage the context. That means that if we get some information from the training algorithm here, that the data seems odd, right? We know what the data looks like at the moment where the training was working. We know exactly at this point in time what it was looking for, what it was looking like, sorry, right? Therefore, we have an instantaneous picture about the problem that we have at hand. This is the context of usage, right? Moreover, so we kill, of course, the security problem because there is no need to have this, Kraken that is accessing all the data, right? And moreover, right, you don't have to scan 10,000 data sources, including files. Remember this data lake with plenty of Parquet files that you have no idea what they are, right? They have to be scanned in order to see what's going on, even if they're not even used, right? Because you don't know, but you will scan them anyway. In this case, because there are way less application than data, it will reduce the amount of work that you have to put into data observability too, right? Yeah, but maybe there are plenty of applications. I can tell that working on the data and creating a data set is much easier than writing a piece of Scala, Python, or whatever. It takes way more time, especially with something like dbt. So you have a smaller ecosystem to govern, a smaller amount of problems that can come, and all the problems are already contextualized with application that may have created the problem. Therefore, when you ask yourself where the problem happened for the first time, you're not going to check the data. Because, yes, of course, when we have to check the data, what's going on with the data, right? The data is crappy. Okay, give me access to the data in production now so I can check. 3 weeks later, potentially, you will have access to the data, right? You know why, of course, plenty of good reasons. But 3 weeks after, the data has already changed by an order of magnitude that is almost irrelevant to check it out anymore. So this is what the data problem we have at hand nowadays. So this is data observability, the source, but what can we do in order to create information related to data in our applications? So I'm going to take some pandas code, right? So do you know pandas? Yeah, good amount, right? Spark data frames, even more, right? R data frames, just kidding. They're the same anyway. So basically pandas, Spark data frame, best friend forever. So it's just an interface in order to process some data. So in pandas, what you can do, and you can translate this code into Java, Scala, R, Python, PHP, right? You import your engine, right? You read some data, read CSV. You store it directly. So this is the first step, right? Where we just, ingest the data, let's say, right? And then we read the other data set and we store it into a SQL, right? And then we can even rename columns in there. So what this is doing, right? Basically, we have inputs. So this is an input of your application. This is one of the output of application. So it reads some CSV and then it outputs it into a table, right? And this is the lineage. This is what tells you from where the data comes from, right? This is what will tell you if the customer data is odd, that you may have to check this Python code and or, which doubles the amount of work that you have to do in order to figure out what's going on, and or maybe the customer list.csv. Without this information, right, you have to know that this is a Python code where customer's table is actually being created, and you have to read the code in order to understand where the heck is the data input. Considering that maybe someone has written the code 2 years before, right? It makes it a little bit more cumbersome. The other way that you can do this, right, is introducing, this is kind of pseudocode, right? But it exists, so the library exists, by the way. So basically what you can do is that you can create a logger, like we would do with any other observability tools. You create a logger, right? And then, so that's something that you can do in Python, but you can do this in Java, in other languages. You're going to use specific functionalities allowed by your language in order to do some interception, right? Again, in the third chapter that I'm going to deliver in a few weeks, right? There is a section for all different strategies that you can pick using ASM. Who knows about ASM in Java? ASM, yeah, aspect J, all these things which allow to do bytecode instrumentation and so forth, right? In order to extend your application with extra capabilities. In Python, we do something a little bit odd, right? But I find a little bit fancy too and curious. We can do something called monkey patch. Do you know monkey patch? A little bit, right? So for the Ruby out there, so they know exactly what I mean. So basically, you take your function, right, and you replace it with another one dynamically, right? Of course, it doesn't lead to any problem. So here, in this case, what can be done, right? So instead of importing pandas as PD only, you can have a monkey patch which is going to add plenty of functionalities to the function that you want to extend, because you are reading the data, you're writing the data, so you know that you have to catch that some data are actually inputs, some data are actually outputs. Because the code that you can inject knows that these are data sources, files, database, whatsoever, they can extract at the same time information about the schema of the file, the location of the file, etc., the security attached to the file, etc., etc. Both for input, outputs. And with some monkey patches, I said, you can also connect the different input and source and targets, outputs, in order to build a lineage. And this is what we do in open tracing. With open tracing, this is exactly the same kind of thing that we do, right? So we connect the input with the output, but these are services generally, right? But here we do it at the data level, right? So we connect the lineage. This is how we can do it. Spark, in this case, is PySpark, but as you know, both APIs are relatively similar. Here, we read some data using the Spark context or the Spark session, whatever. We write here to the different CSV file, okay? And here we have some filters, we have some computations, like we take two different columns, what do we do with them? We subtract them, right? And then we create a new column, and then we can select exactly what kind of information we want to store, right? So here the code is of course simple, but when you have 300 lines of code to describe your pipeline, right? This is where it's becoming messy, especially when you're writing them in SQL. So in this case here, what's interesting is that maybe some data are not there anymore. Maybe one of the fields is not provided is not in the CSV file anymore. Maybe the name of the column has changed, right? So many things can happen, right? Maybe the file is not even there. So, which probably has happened to at least each of you once, right? So there are plenty of things that we assume will be correct that we don't check. And to be honest, this is what we deploy in production. Huh? This is exactly the kind of thing that we deploy in production. No check, no precondition, whatsoever. We just deploy that because it worked on my machine / on the cluster. And of course, from there, you can connect the inputs with the outputs in order to generate the lineage. So instead of writing everything by hand, again, what you can use is you can leverage what the library or the code that you're, the library or the framework you're using. In this case, this is Spark, right? And if you know Spark, you know that there is a DAG in there, right? So the direct acyclic graph, which allows you to reconnect the inputs and the outputs, right? So in this case, you can leverage this capability that Spark offers in order to catch the DAG and then recompute what are the inputs, outputs, at the same time, look at the schema, look at the presence of the files, compute some extra metrics, and log everything to an observability, data observability or observability platform, sorry. So here we have the extra information, so we extract everything from the data frames in this case, and so on and so forth. Checking my time. So scikit-learn, you are aware of what scikit-learn is? Yeah, TensorFlow, a bit more, right? So basically, it's a library to train and predict models, right? It's probably one of the oldest in the Python world, right? Of course, TensorFlow has a great momentum for the last 5 years, but Scikit-learn here, so we read some data and we write, in this case, not some data, but we write a model. But for me, a model is anything but just another data source, right? Because you can read it and we can use it. So here, we read the inputs and then we output a model. And we can still do some selection, so we have to do some filtering, only even for the training set. And then we have some transformation, which is exactly the analytics part of it. So remember, there was an analytics observability. In this case, the analytics observability is all these things: select, filter, transformation, and so forth. The information is there. What I mean by this is that when you write the code, you are creating a massive amount of information that describe what the transformation will be. It's already there. So what should you actually reprocess this information in order to reconnect the dots afterwards? Or write documentation that will be outdated at the next update. So how to do this? Again, so you can leverage the peculiarities of Python by doing some monkey patching. You will extract all information about the read data, the written data, and including when you're going to use the model at the end, where you can accumulate information for the lineage. And then, again, yeah, sorry, I already told this, the lineage part. Finally, the prediction. I will skip this really quick because it's pretty similar, right? The thing is, because I want to pause on this one a little bit, right? It's important to have observability for the machine learning that goes in production, right? Because of the concept of model drift, data drift, or whatsoever. That means that at any point in time, your model is going to be quirky, right? So it's not like eventually the model will not work anymore. No, I can tell you that at some point in time, the model is not going to work anymore, right? You just don't know when and why. But I can tell you, 100%, it will be wrong at some point in time. Right? So therefore, in order to anticipate this, to understand when you have to act on it, retrain or whatever, you need to collect information about both the model, the prediction, and how the model has been created. So this is what I propose here. And therefore, what I can do is a small showcase that has run this pipeline. Checking my time, yeah. It's 45 minutes, it's almost done. A small showcase where we have this, this pipeline being run. So for information, so you can go on this public repository. So the pipeline is defined, right? So you can run it using Docker, and then you will see what kind of observability information are published through this API on this free of use platform. Oops, sorry. In order to show you this really quick, so I hope that okay, so I'm connecting it to the platform. Is it okay? Actually, it's not too big. Maybe it is. So what happened, right? So actually, when you created the font is a little bit bigger. Okay, good. There you go. Well, too much. Okay, so basically what happens is that so when we run the pipeline that you can run on your own, right, with using Docker, right, it's going to create a ton of information, such as, oh, now the applications are running in a project that is called, let's say, a marketing project, right? So you know that different applications are part of a project named marketing. Why? Because in Maven, POM, or SBT, or settings.py, or whatever, you define that this project is actually marketing, right? And in this project, you have multiple applications. The different applications that I was talking to you about, right? The different Python load, where you load the data using pandas, and then you have dbt that is running in the background Spark in order to process the data. And then you have the application that is pushing information into the data mart in order to allow the data analyst to perform some queries and analytics on it, right? So by having the information flowing from the applications about the data, you are able to connect these applications together, right? And this is not exactly what would provide observability by default in application observability world, right? Because here, the applications are not connected at all. They're not calling each other, right? What happens is that the Python load, data load application is producing data that later on is going to be used by another application. So there is no connection at all between the application, but at the data level, right? So this is the kind of information that we need to have in order to perform a root cause analysis in an efficient way. In a way, this is, I like to call this also a distributed stack trace. So you have a stack trace that continues another machine, et cetera, right? But at the data level. And in each of these applications, right, you see that we have two pipelines because the data files are used in different pipelines, right? And what you can do is that you can jump into whatever, one of these applications, right? And the application tells you, okay, me, the DBT orders and customers application, and consuming two tables, public orders and customers, and I'm producing this schema and orders table. This is my responsibility. This is what I'm doing, right? It's not like for who knows about data lineage and saw a data lineage in their life, right? In most of the tools, you have like a gigantic graph of data source connected, and you have no context. You don't know why data connected for whatever reason. So you have no context around it, as I said, right? So you don't know which application are using which data, et cetera, and you have no project data, right? And that makes the lineage unusable, right? Here, the idea is that you can, using data observability at the source, you can have this context that will drive you throughout the process to use this gigantic lineage that is hidden behind this. It's just a filter, if you want, but a filter on the application level, right? That's, to be honest, for whoever has been performed a root cause analysis in a data pipeline, right? This takes actually weeks, if not months, actually to get. And afterwards, right, what you can do is that you have these data sources which have data being published. So I don't know if I have some data for this one, but not a lot, right? But I will go to another one to show you a bit more information, right? In this one, I have a pipeline, and one of the pipeline has a problem because what happened is that I created a rule. Remember the expectation I was talking about, right? So you want to have rules on the data set. You want to know if at some point the data that you consume or produce, right, are not matching some of the expectations that you have. And for this, we use rule like Kibana or other observability tools, right? In this case, the data set that I'm showing here, I'm going to select all the information that I have. So these are the observations, right? In this case, these are metrics. Metrics about the data set that I'm currently reviewing. And here what I'm showing is the history of how the data, again, KPI, right? KPI conversation rate tests, right? How this KPI has evolved over time. When every time the application that is creating this KPI has run, right? So every time the application runs, it says, okay, this is what the KPI looks like. Okay, this is what the average of the KPI looks like. Okay, this is the amount of nulls that you have for the table KPI, right? Every time it runs. That means that you have the history of the behavior of the data, right? And you see here that at some point, right, I believe for the rate here, well, at some point the rate is actually quirky, so there is a kind of a gap in the data, not a gap, but a valley in the values of your rate, and therefore there is a peculiar event that is attached to it, pretty much like you would have with CPU load or memory or whatever. You see, oh, what's happening now? We have a peak. But here it's data, right? It can happen silently without any notifications, right? Unless you compute information that you want to be aware of, right? And this, in order to have this information, right? Remember, this is a data set. This is a table. This is a table in Postgres, right? If at some point you didn't produce information along the process, right, you will be stuck at analyzing why the data is crappy by using only that point. Because this is gone. You will never be able to recover it. So you have only one point. You see how hard it is, right, to find a problem with only one information. So this is the kind of capabilities that allows data observability, providing insights, information about how the data behaves, right? So nothing more than that, right? For engineers like us, it's trivial, but now we have to spread the word in the data ecosystem now to make sure that these best practices can be used. To finalize on this, so I will leave this open, right? So for you guys, so there is a virtual lab that I will run next week. So we can actually work together on this kind of pipeline, right? There is one thing that I want to add. Have you heard about data testing? Data testing, anyone? No, a few, only a few. So data testing is a practice that is when you write your code, a pipeline, you test your code with the data that you have at hand, right? And this validates that you can go in production. That seems okay, right? I mean, in a way, it's a good practice. But what happens is that you check plenty of things. So imagine, assert that the column age exists, assert that the file exists, assert that the age is greater than 18, assert that, all these assert are in the test, right? So they are true during the CI/CD pipeline, but at any point in time, they can be wrong in production, right? So instead of having tests, having the assert that I just mentioned in the test files, please put them into the code, right? Check them in the code that goes to production, because at any point in time, this can be false. And in the test, check your business logic. The business logic has to be checked with samples of data. There is nothing wrong about it, right? But never assume that the data will remain the same at the end, because another person, it will change. So, yeah, this is ending my talk. So please join the virtual lab if you want to play with me with this kind of concept. And as I said earlier, there was the Slack channel. So do I dare going in the Slack channel and see if there are people asking questions? If people have asked questions, they will say, yeah. So I guess there is no point in going there. But it was a pleasure. And don't forget, if you want to read the first chapter, the third one is going to be on a few weeks max. And yeah, I hope that I did a good job. Thanks a lot.